Hello and welcome. Thank you for joining me today. We're going to be talking about quality assurance, also known as QA in software development. And my name is Alexandrea Beh. I'm currently a senior software engineer at a wonderful ed tech startup called Mentor Collective. But to start us off, I'd love to take a moment and get to know some of you in the audience. So if you could use the chat, or I know some of you have your video on, give me a wave. How many of you are currently students at the Tech Academy? Hello. Graduated in September. Congrats. Great. Okay. And how many of you are currently in a software development role? And I realize there might be some overlap here.
Yeah, I actually recently got a job as a web developer for a company called Plain Concepts. So that was about a week and a half ago. I officially start in January, so I can officially say that I'm a software developer now. Just exciting.
Congrats, dude. That's really exciting.
Thank you.
Anyone else? Okay. And just on the off chance, is there anyone here who is in a QA role? Okay, looks like no. All right, so thank you all for sharing. Let's dive in and learn more about QA. When you hear QA, you probably think bug. And today, debugging and bug management are really, really important parts of development. But did you know the first recorded software bug was literally a bug? I wanted to share this snippet and this photo from National Geographic. This is a photo of the first actual case of a bug being found. Yes, exactly, Jerry, it's a moth. So one of the team members from Harvard University wrote in their logbook, first actual case of bug being found. They were working on a computer known as the Mark II, and the computer was delivering consistent errors, and they opened up the hardware, and they found this moth, and that moth had disrupted the electronics of the computer. So among the team who found the first computer bug was Grace Hopper, who you may know. She was the inventor of the language COBOL, and she's often given credit for reporting this bug, but it was really her entire team. However, she is likely the person who made this story really famous. It's a good question. I don't know what made the moth really attractive. Maybe there were a lot of blinking lights, something like that. So a little bit about me. This may be a similar background to some of you. I don't have a traditional computer science degree. I graduated from Pacific University with a degree in biology. If you had asked me when I first went to college what I wanted to do, I would have told you that I wanted to be an optometrist. That didn't come true. And I ended up with a biology major and a computer science minor. I hadn't touched web development, but I learned the basics of programming. Once I decided that I wanted to be a software developer, I found online resources and kind of self-taught until I found my first job. And I never got an internship because of that experience. So none of my classes and materials that I used for independent learning mentioned QA. I knew that software development was about writing code, and I knew I had to test my code for class, but I didn't know how testing played a role in the industry. So that also sounds like you. I hope you'll learn something new from what I have to share today. And excuse me. To start off, I started my career at a company called NAVEX Global in Lake Oswego. They're an ethics and compliance company, and I worked on their user and platform kind of internal tools team. That team was about 3 to 5 people, and I'll tell you more about their processes later on. And then I moved on to SurveyMonkey, who's now rebranded as Momentive. They rebranded, I think, a few weeks after I left, so I'm still making that switch in my head. If I slip up, please forgive me. At SurveyMonkey, I also worked at an internal tools team, and that was in downtown Portland. And recently, about 6 months ago, I transitioned to working at a startup, Mentor Collective. And NAVEX Global and the SurveyMonkey Momentive teams were somewhat similar. And then working at Mentor Collective has had a very different QA experience. And so I'll be comparing and contrasting what those were like. But I do want to point out that QA is not just a job. When you're searching for jobs, you may see job titles as QA engineer, software engineer, and test. And in that case, QA is a role. But I strongly believe that QA is at least a responsibility in every engineering team, no matter what role you play. So we'll talk about similarities and differences there. At a high level, we'll also talk about different tools and strategies for testing. But first, I wanted to kick us off with a brief video.
This is a square. Can you guess which spot that goes in?
The square.
That's right. It goes in the square hole.
Yes. Okay.
And how about this rectangle? That one
Also the square.
that goes in there too.
Yeah.
Up next, we've got this thin rectangle.
The thin
Can you
rectangle.
guess where that goes?
The thin rectangle.
That's right. It goes in the square hole. And up next, a cylinder.
The circle.
I think that goes in
The circle.
the square hole. Now, we've also got this semicircle right here. Do you see a slot that would fit
The semicircle.
semicircle?
The semicircle.
That's right. It's the square hole. Okay. Up next, the triangle. We know what hole that goes
The
into,
triangle.
right?
Triangle.
That's right. The square hole. And up next, we have the arch.
The arch. The
And
arch.
you guessed it.
The arch.
It goes in the square
Oh,
hole.
God.
All right, so when you see that video, how do you imagine the interactions are between that developer and QA? It might look like this cartoon where they're kind of fighting and throwing things at the wall saying, it wasn't me, it wasn't me. That's not an ideal situation, even if it's a funny video. And in some teams, QA operates very separately from the people who are developing the initial code. And that can lead to a literal or metaphorical wall between the two roles with people on each side. We call it throwing issues over the wall, kind of playing a game of hot potato, if you will. You can probably imagine doing that is not a very collaborative dynamic. I've been lucky not to work in that kind of environment directly, but I have worked with people who have seen that dynamic, and they tell me that it's not as effective and sometimes can turn outright toxic. So today, I hope that you'll learn something new about QA, but I also want to talk about what a healthy QA culture looks like and providing tips on how to find or create and encourage that kind of healthier culture. A little bit about how a QA worked at NAVEX Global. Development teams had about 3 to 5 developers or engineers, and each team had 1 or 2 dedicated QA members. When each team had 1 or 2 dedicated QA members, we also call this embedded QA. And what that means is that when the team is discussing building a new feature, even when it's in the planning stage, your QA members are part of that discussion. They're part of the discussion as things are being built, all the way up to when it's ready to be tested and when it's ready to be launched. And this is different from some teams where QA doesn't see or know anything about what they're testing until it's ready to be tested. And one of the advantages of having embedded QA team members is that when you're at the planning stage, before any code has been written, QA members can be really valuable by pointing out what kinds of features are going to be really tricky to test, or what kinds of features may mean that if we're not careful, this other part of a product might break. And let's build time into our plan to make sure that everything is going to be reliable. Our QA members did both manual testing and automated tests. So manual testing is what it sounds like. In web development, that would mean you have a person who says, these are the requirements, this is what was built. I'm going to go into my browser and act like a real user and make sure that everything works. Automated tests involves writing code, just like a developer would. And that code uses a third-party library that essentially automates the browser. And it looks pretty cool. If you've ever seen this, you can find videos of it. Imagine that someone was recording themselves testing something in a browser, and then you speed it up really, really, really fast. That's what an automated test can look like. And so that involves a lot of logic. And then at NAVEX Global, we had a custom test framework. It was built on top of software called Selenium. And some of the processes that were involved in QA included nightly regressions. And so that meant that key tests, like let's make sure login works, let's make sure that this core sign-up process is always functioning. Every night, with whatever new code had been pushed, those tests would run. And if anything had failed or regressed, so it used to be working and now it's not, the next morning everyone would wake up and see an alert or a list that, okay, here are the things that we have to fix before it actually gets launched. And we also had something called smoke tests, and that's what this diagram is about. A smoke test comes from the construction industry, actually. It originated from the practice of construction workers injecting smoke into water pipelines to make sure that those water pipelines didn't leak and help avoid floods. And in the software development world, what a smoke test did is say, hey, I have this new piece of code. I'm going to merge it, deploy it to hopefully a test environment, and smoke tests are going to run. It's a core set of tests that someone has decided is the most critical to whatever you're building. And if those smoke tests fail, something's really, really broken and you don't want that code to get any further. Something needs to be fixed. It's a very quick way of finding out whether or not code quality isn't good enough and whether you need to go back and fix something before it gets too far. So I mentioned manual and automated testing. QA used to be, if it was just a role, QA used to be all manual. And the reason why I have an image of stacks and stacks of papers and binders is that I once talked with someone who used to do entirely manual QA. And what that meant is they had a binder printed out with test cases and steps one by one of here's what you need to do in order to make sure that this product is functioning. And they would flip through that binder and go through pages and pages and pages that only grew as time went on, the longer you had a product. Here are the things you have to do to make sure that everything is functioning. You can imagine that's pretty tedious, not as fun as writing code, at least in my opinion. QA is changing. Some testing is still manual. Oftentimes, writing an automated test can take time, and maybe you want to deploy and launch a product or feature before all the automated tests are written. So in every organization, it's a little bit different, but a manual test might be good for saying, okay, we can deploy this, but I don't want to keep manually testing this day after day. Most people don't. An automated test, once you write it once, will continue to run so that nobody ever has to do that manually. Automated testing requires understanding how to code. You have if statements, loops, classes, and objects. You have to organize your code so that it's reusable and easily readable, just like anything else. It might involve performance testing, depending on what product you have, making sure that something isn't too slow. If you've ever been to a website that takes forever to load, what's your reaction? I guess I'm just going to close this tab, right? Most of us don't have the patience anymore. And so those kinds of things are really important to test. It might involve testing APIs, depending on what you're working on. It may involve writing SQL or looking closely at databases to verify what a test result should be, because sometimes it's not obvious and you have to know your data set in order to know what's the right state that I expect something to be in. It also involves having flexible designs. A code base is always changing, and that means that tests will occasionally need to change as well. So QA at Momentive, at the time SurveyMonkey. Initially, when I joined the team that I was on at Momentive, it was an internal team that had no QA. And this is a little bit unusual because that particular internal team used to not be part of engineering at all. It was started by a couple of people in customer support who learned programming, were interested, had a need for automating certain things, and started to develop tools. Over time, that team grew, got absorbed into engineering, and for some reason or another, didn't have a QA engineer yet. And once we did hire a QA engineer, oh my goodness, I was very, very glad to have her. It was also a mix of manual and automated testing, so similar to the setup at NAVEX Global. Originally, we used Test Cafe, which is another third-party testing kind of framework, and eventually transitioned to React Testing Library. If you work in React at all, I would highly encourage you to check out React Testing Library. And it also included design consistency and UX. My particular internal team didn't have a designer, in particular because it was internal and not a product-facing team. So the person in the role of QA often played the role of making sure that when we designed something, that the user experience was consistent, because that is also a part of how someone perceives quality, right? And this QA person was also our go-to for complex business cases. The SurveyMonkey and Momentive products are pretty extensive at this point, and that means you could have many, many configurations in which to find bugs, and it can be hard to keep track of them all. Our QA person was the person who really kept track of that. QA was also really critical for cross-team projects. There were over 300 engineers in the entire company. I don't even know exactly how many engineering teams that translated into, but it was a lot. So imagine when you have a cross-team, company-wide product launch or new feature that touches multiple teams. How do you make sure that everything works together? How do you make sure that you don't have bugs? Well, you need QA for that, and you need QA across multiple teams to collaborate. QA was often the key influencer for whether or not something would launch. And for where I am now at Mentor Collective, QA is not a dedicated role. I work on a team of 11 engineers. We're split into 2 teams, around 5 to 6 people right now, and we're looking to grow. But for now, we don't have dedicated QA, and so QA is a responsibility. And we share that responsibility between the engineers, designers, and product managers. We still have a combination of manual and automated testing. The designers and product managers do the manual testing, and engineers do the automated testing. We write unit tests for certain things on the back end that might just not be easily testable from the browser. And then we write end-to-end tests in Cypress. And what is an end-to-end test? It's basically what a user would do. So when you think about clicking around in the browser and interacting with that front end all the way down to fetching data at the back end and what that might look like, that's end-to-end. As part of QA culture, because we don't have someone in a dedicated QA role, there are other ways to pay attention to quality. And some of the ways that we do that are running tests on every single pull request and code merge. Nothing gets into our main branch and deployed out to production without every single test being run, and every test must pass. In addition to that, we have code reviews, and some places at NAVEX Global and SurveyMonkey, it was usually just one person needs to review your code. But at Mentor Collective, we have 2 engineers review our code. And that's an added buffer to just try and catch bugs earlier. And with that context, you might be wondering, okay, hang on. When does it make sense to have QA as a role? And when does it make sense to have QA as a responsibility? I don't have any hard and fast rules. I don't think there are any hard and fast rules. But I do think there are some cases where it does make sense for engineering teams to be more heavily reliant on QA and a little bit less. And so this is a chart of the startup lifecycle that can help explain some of that, at least in the context of startup life at Mentor Collective. So at the very, very left of this chart, we're searching for problem, solution, and fit. When a startup is at its very beginning stages, they're still trying to figure out what their product is, who their audience is, Like, what problem are you solving and who are you solving it for? And that might change over time. As you get further to the right, you start establishing what we call product market fit. And so for Mentor Collective, it might be we form mentorships that help students at colleges and universities. There's a little bit more that we do, but I'm not going to get way too much into that. As you get further to the right, you start being a lot more confident in what value you provide to your users and your customers. But when you're still really figuring that out, what matters most is validating your ideas and getting your ideas out there. So if you spend a whole bunch of time in QA stages at the very beginning, building the perfect thing, only to launch that and find out that's not what anybody wants, you've wasted a lot of time and resources. In that stage, QA is not as useful. But if you're a really, really large company with an established customer base, where even the smallest bug is going to lose you a lot of money or a lot of credibility, really affect your public reputation, you can bet that company at that stage is really going to care about QA. So a lot of how QA shows up is going to depend on where the business is at. Here's another chart. Don't take these numbers literally. I've seen some charts that label these axes at 10,000 magnifiers and 1,000 magnifiers. I think the point of this chart is that the longer it takes for you to detect a bug, the more expensive it is to fix in terms of operating a business. So one of the ways that QA is valuable, no matter how you're practicing QA, is that the sooner you can catch a bug, the less it costs the business. So remember I talked about having embedded QA. If you're in a planning meeting and someone is writing out requirements and those requirements are missing something major that could lead to a bug, if someone notices, hang on, that's going to lead to a bug, maybe that took a 5-minute conversation, right? If you have a flaw that is caught in design, maybe the designer has spent a lot of time creating those designs. And if you have to change something, you've lost the amount of time it took to create those initial designs. A little bit more than a 5-minute conversation, but still not way too bad. In development, you're talking about the time it took to write the code, to maybe write unit tests for the code, to have somebody review it, the time it took to go through whatever other automated processes you have. Now that cost is starting to grow. And if it gets to testing or it gets launched out into production, right, that cost can increase exponentially. So one of the things QA does is try to minimize the number of bugs that you find at the very right-hand side of this graph. However, if you work in a highly regulated industry like finance, healthcare, or aviation, you are likely to find a lot more QA. And again, thinking about the business context. If you're in an airplane, you want to be able to rely on the software running in that airplane, right? And if you have a bug, I have a friend who works for Garmin Aviation. If you have a bug, you can't just fix it and deploy to the hardware running on that airplane. And so if that's your business model when you're writing code, you're going to want to pay a lot more attention to the quality of what you're shipping. Versus at Mentor Collective, we ship code multiple times a day. You still don't want to release bugs, but compared to putting code on hardware that's in an airplane, the cost is pretty low. Similar thing, a medical care device. Maybe someone's life depends on that device. Or in finance, it's a heavily regulated industry. Nobody wants to see bank errors or key financial transactions that don't go the way they're supposed to. All right, we've been talking about QA and testing a lot. You might find yourself working in a job that does intersect with finance or healthcare, but you might not. But one thing I'm pretty sure you are going to end up doing is interviewing. So this is a real interview question that I've asked both developers and QA engineers in the past. And I want us to do an interactive exercise. and see how we do. So please open up the chat if you don't have it already. Imagine that you're in an interview and you've been asked, how would you test a chair? How would you answer? We'll take a minute or two, and then I have a slide with some suggested answers. Dan says sit in it. That's a good place to start. David doesn't trust the chair yet. Put some weight on it first before sitting in it. Right. Good ones. What else? Center of gravity. Yeah, how easy it is to just, when you lean back and then go, oh, I'm about to fall over. Nobody likes that feeling. Test the wheel. Does it roll? Does it recline? Yep. Okay. Now we're starting to think a little bit more outside the box. Check the armrest if it has armrests. Comfort. Okay. So something I didn't say. What kind of chair is it? Is it a booster seat, office chair, dentist chair, motorized wheelchair? All very different functions. One of the things, it's a little bit of a trick question. I know, I tricked you. One of the things when you get a kind of interview question like this is you might have some initial reactions, and it's good to talk out loud and say, okay, here's what I'm thinking. But imagine that you're being asked to build something as an engineer and the product manager comes to you and says, I want this. One of the most important questions to ask is making sure you understand what they want before going to build the thing or test the thing. And so that's why I put, what kind is it? What kind of chair is it? What is it supposed to do? And once you understand that, once you have more information, then you'll probably have a more detailed answer on how you might test it. So with that, let's try again with a slightly more realistic example. Also used this in interviews before. How would you test a login form? Now we're getting there, much better. Who is the intended user and what is this login for? Yes. What interface is used to display the login form? Good. What additional pieces of information are there? I haven't said anything about the inputs. What are you tracking? Get a couple more ideas. No. What did the form do with the data? Yep. Okay. So at NAVEX Global, part of what my team did was the login flow. So I've taken some real things that I've seen and listed them here. Some of them we've talked about. What are the fields, right? But also what happens when you have invalid input? What happens if, assuming there's a password, somebody guesses too many times? Do we need to be worried about security? What happens if someone has a bookmarked link, but they're not logged in? And then something that's becoming increasingly important is accessibility. Let's say you're working on a government website, or these days, really, any website needs to be accessible. The internet is so important for so much of what we do, but accessibility is sometimes forgotten. What happens if you have someone with low vision? or someone who needs to have the screen just be enlarged a lot. I got my eyes dilated once and everything was so fuzzy. I was trying to increase the font size everywhere. What is that experience like? What happens when you use a screen reader? Something someone once pointed out to me is that in some login forms, the only way you know that your input was bad is that something turns red. But what if someone can't actually see that color difference? Do they have any hint that something was wrong and they need to fix something in the form? Right? All of these things could matter. So you might do well as a dedicated QA person if you really care about those kinds of consistencies. QA is also really about building trust. I remember that example about if I get on an airplane, I want to trust that that airplane is sound, that all the code running on it is working. Same thing with a car, right? Same thing with where I bank. So many things run on software, and we want to be able to trust those things. QA is a big part of building that trust. And a big part of that, we were talking about accessibility, is also the user experience. If you really care about the user experience, QA is one big way to affect that. As well as being detail-oriented. The best QA engineers that I have worked with love their spreadsheets and their checklists and writing out every test case and being really, really thorough. And that's a skill that not everybody has. And if you have that strength, it can be really, really valuable. Thinking outside the box is also really valuable. When we're writing our own code, it's really easy to say, okay, I know how this works. I'm going to test it out. But it's kind of like when you write an essay and you think you've proofread it, and then you read somebody else's work, or somebody else reads your work, right? It's always easier to catch somebody else's mistakes. And something that people may not consider is that someone who does well as dedicated QA probably should like to offer feedback and be able to do that in a really constructive way. We'll touch on this later too. But if a developer is saying, how can I make it? And a tester is saying, how can I break it? If a QA person figures out how to break something, they find a bug, guess what's next? You have to go to the person who developed it and say, hey, I found a bug. And there are lots of ways you could communicate that. Some not so nice and some a lot more collaborative. But there has to be some kind of communication there. And so you'll do really well if you're able to offer good feedback. But regardless, you're likely to end up having to test things in some form if you're coding. And so I put together a list of, from a developer's point of view, how to be QA's favorite person if you end up working with someone who is in a dedicated QA role. And the first thing is make sure you both understand the requirements. There have been quite a few times where I send something to be tested and what I hear back is, this doesn't work, or this is a bug. But we disagree on what counts as a bug because our understandings of the requirements were different. And so establishing what the requirements are and making sure that you agree on them is usually step number one. Step number two is testing your code. Just because you have someone who is dedicated QA does not put you off the hook for testing your own stuff. And it's always great once you have tested your own code to include notes of, this is what I've tried. Going back to giving and receiving feedback constructively, I think one of the most valuable things about working with someone in a dedicated QA role is learning not to take things personally. Because it is a QA engineer's job to find bugs so that as a team, the quality of code is high and that the user experience and the product is really great. They're doing their job if they find a bug and come to tell you that there is one. And if you take it personally, it hurts the entire team and the goal of trying to create great code and a great product. And then tracking your common mistakes. Everyone's going to make mistakes, but if you're creating and causing the same kind of bug over and over, that's not ideal. And so do everyone a favor, keep a list of what your common mistakes are, and checking through that before you send something to be tested. How do you get better at testing? Again, tracking your common mistakes. I like to keep a list in Trello because it's hard to keep everything in my head. It could be a sticky note on your laptop, whatever works for you, but just having a running list of, oh yeah, this is the kind of thing I tend to forget. Understanding the root cause of other bugs, especially as a junior developer, I loved kind of sitting on the sidelines, being a fly on the wall to see what other bugs people came up with, what other things got reported, and trying to understand what caused that and learning that way. Similarly, by code reviewing other people's code or seeing how other people review code and how they test, you can get better at testing. Also remember that you are not your user. The vast majority of us writing code are going to think about how we interact with websites and other things pretty differently from the average user. And so remembering to have empathy and think like somebody else can go a long way into realizing that, oh, somebody else might just put every single block into the square hole, even if that's not what I intended. The other thing is that if you go on sites like LeetCode or places that have test cases, that can be a good way to check yourself in terms of making sure that you've covered multiple test cases. And then going back to interviews, because you're all likely to have interviews at some point, here's a list of some questions that you can ask about QA culture. In particular, are there dedicated QA roles? Not every engineering team has dedicated QA. And even if there is dedicated QA, how is it done? Right? Is it done manually, or is there automation, or both? Is QA fully embedded into the team? This can really change the dynamics of your QA culture if you have a dedicated QA person in every single team meeting, or if they're siloed somewhere else. And then lastly, I think this one is really important. What best practices does the team use to ensure code quality is high? Remember how I talked about 2 engineers at Mentor Collective always have to review a pull request? What are the standards for code reviews? Are there guidelines for what makes a good code review? How frequently are tests run? How do you decide something needs a test? All this can vary, and all this contributes to a culture of QA. All right, I see there's a question in the chat. What tools do you use to report feedback or communicate quickly? Yeah, so right now at Mentor Collective, I'm fully remote, and so we are on Slack and Zoom quite a bit. And our tasks are coordinated through a project management tool called Asana. But honestly, I have all those notifications linked into my Slack, so it's basically all just Slack and Zoom. Good question. And that actually wraps up what I have to share today. I'm happy to take more questions, but I do hope you learned something new, and that no matter where your career takes you, you'll be able to find or encourage a healthy QA culture. I'm sporadically on LinkedIn, so feel free to connect with me there. Happy to be a resource for you if I can. But otherwise, I'm happy to ask questions or answer questions. What testing frameworks do you use? Yes. So in terms of testing tools, at Mentor Collective, we use Cypress.io. So that's for end-to-end testing. And then for unit tests, it's just Rails unit tests. Is it BDD, TDD? Yeah. So I wouldn't call those frameworks, but rather strategies. For those who may not know, BDD is behavioral-driven development. TDD is test-driven development. Strategies, yeah. TDD is like, write the test first, see that it fails because you haven't fixed something yet. And so verify that something is broken. You fix the bug, and then you see the test passes. I think TDD, which I've used sometimes, is really useful when you already have a bug. I don't always see it as useful for new feature development because sometimes you're developing a feature and you think you know how you're going to code it, but then halfway through you learn new things and your strategy changes entirely. And so if you spend a lot of time trying to write a test that fails and then completely change how you're writing that feature, that time spent making the test may just feel really fuzzy and not as useful because then you have to go rewrite it. So I do find TDD useful when you already have something established and you know that there is a bug. BDD, behavioral-driven development, that one can be a bit fuzzy, but I do think it's nice because it's very user-oriented. And that's another thing. Mentor Collective uses a lot of end-to-end testing, which is very focused on the user behavior. So it starts with the user went to this tab, clicked on this thing, and expected to see this. Right? That's very similar to behavioral-driven development. Yep, exactly. I think it's really useful to be user-oriented. Other questions? These are good questions. Do you use all of them? I would say yes. There's not a single strategy that I stick with. It really depends on what you're building, what you're writing.
Any other questions? Oh, there's another one I see.
Tech stack, yeah. At Mentor Collective, the front end consists of React. Our middle layer API is with GraphQL. And then on the back end, we've got Ruby on Rails. Then underneath that is Postgres. I've worked with a few different tech stacks. Before that was React and GraphQL and Python, and a combination of MS SQL Server and MySQL. Before that at NAVEX Global, it was a little bit of React for some things, but a lot of .NET, C#, much more Microsoft tech stack. And across all those different kinds of tech stacks, tests were always important, just maybe the frameworks that you used were different. Ooh, this is a really good question. Yeah, what are the criteria for approving a pull request? So I'll talk a little bit about, at a high level, what I look for in a good pull request. And this is something that in all my engineering teams has been a team discussion. Really important that instead of just, here's a set of rules, that every engineer involved in approving pull requests actually gets to discuss what they value and what they expect the pull request code review process to look like. I do encourage people to look up Google's guide to pull requests. There's a really, really great set of articles on that. But in general, the first thing that I look for is, do I understand what's happening? At Mentor Collective, we use pull request templates. And so there are guidelines like, please link to the Asana card so that I can read the business reason for why this code was written in the first place. Because when you have multiple people on a team, after a while, you can't keep track of every single thing being built. And so when I go into review code, I will usually click on that link to read up on, okay, here's what this person was asked to build, so that I have the business context first before I look at if statements and everything else. And then next is readability. Do variable names make sense? Like, naming is hard. Naming is one of the hardest things that we do. And once you submit code and you're writing in a team, if your variable names don't make sense to anybody else, you're going to lose a ton of time the next time somebody has to touch that code. It might cause bugs, right? If nobody can understand what the code does, or it's so unclear that maybe people make the wrong changes. And so code cleanliness, readability is huge. Another thing as you get to know a code base is reusability. Are there utility functions, shared functions that do things like formatting, for example? That's a really big one. If you notice somebody copying and pasting all over the place, that's probably a good chance for consolidating things so that they're a lot more reusable. And then a little bit of future proofing. When I'm approving a pull request, the more you gather business context, the more you start thinking, okay, we're building it like this now. If the requirements change and we have to extend this code later, how hard is it going to be to change? Like, are we coding ourselves into a corner? And if it feels like we're really coding ourselves into a corner, or this is going to be really hard to change later on, you want to make sure that you understand why you're doing something. Another great question, do you design for a monolith or microservices? Ooh. So to give some definitions first, a monolith is all your code in one place. Microservices is your code broken up into, say, things like, this is the service that just handles users. This is the service that just handles billing. A lot of that depends on the company, the business case, how large your code base is, how many people you have. I think there's a time and place for each one. And a monolith makes sense when you're starting out most of the time, because if you spend time breaking code up before knowing how it's really going to be organized as like a mature product, or you just have 3 people working on something, you don't see a lot of benefit in breaking things up into lots of microservices. When you have, say, 5 teams, it might make sense to have microservices, or to have your code bases broken up so that they're not constantly stepping on each other. But that's a really tricky question, and there are a lot of blog posts that go into why and why not. Some of them are heavily opinionated. I tend to fall in the camp of there is no single right way. If somebody says you should always do a monolith or you should always have microservices, there's usually a lot more nuance there on what the pros and cons are. What's an example of coding yourself into a corner? Yeah. So an example of coding yourself into a corner might be, let's say we have, let's see, I'm thinking of something from work and trying to generalize it. So at Mentor Collective, we have schools, you have partners, and then you have users. Let's think about how custom that experience might be when somebody logs in. If you say we're always going to do something based off of what school you belong to versus what individual user you are, that might be a very big shift in terms of what information you rely on. And so if a lot of your code assumes that you never have user-specific things, and then product says, okay, now we want a whole bunch of user-specific configurations, it might take a lot of effort to refactor your code in a way that supports that requirement. Whereas there might be a middle ground to say, we're going to do this by school for now, but you might write the code in a way that you don't have to change it all later. Do you tend to use SQL or NoSQL? Mostly SQL, but I will say that Postgres is really interesting because Postgres offers a bit of both worlds, because Postgres has a data type called JSONB, and that lets you have a column that essentially stores a JSON blob object. And you get a little bit of the benefits of NoSQL there, while the rest of your data is still structured. You use the cloud heavily. Probably not as heavily as some other companies. Mentor Collective runs on Heroku and AWS. And in terms of AWS, we use a few services, but there are many, many, many AWS services.
Any other questions? These have been so helpful so far. Okay, looks like we got one more.
You all are full of questions. Server or serverless? That's not something that has been applicable to what we're doing at Mentor Collective right now, although I have worked with serverless before. It can be really useful.
Any
All
other?
right, well, Alexandria, I'm sure this was a great talk, and I apologize. I usually do these talks with Rogina. I had something come up at work, but we do record these, so I do look forward to going back and watching it. I'm sure it's great information. And one question I did have, and you may have covered this, so I apologize, but what would be the #1 advice you would give our students as junior developers starting their first job, say as like a QA tester or a test engineer? What would be the #1 advice for starting out?
That testing might seem tedious and frustrating sometimes, but to remember that testing is all about building trust.
Sounds good.
I think there is one last question in the chat box, and then
Perfect. Yeah, will you describe serverless at a high level? Serverless is a really interesting name, and serverless code still runs on a server, which is why it's an interesting name. Like all code still has to run on a server, but the idea of serverless is that you don't have to worry about the underlying infrastructure of what you're running on. When you use AWS serverless like Lambda, you can say, okay, I have this JavaScript or this Python function, and I want to do this thing. And let's say I want something to run every hour. You can use serverless really quickly. Say, here's the code that I care about. Here's the language I'm writing in. Here's what I want it to run on. And if you have very simple code, I'm simplifying here a little bit, but if you have fairly simple code, you can be up and running very, very quickly without having to worry about how do I get this to run. Again, that infrastructure piece. What can also be really useful about that is you can scale it. If you're not worrying about managing that infrastructure, you can say, I want this to run every hour. I want this to run every 5 minutes. I want this to run in parallel with 200 instances. And depending on your use case, that might be super, super useful. The one application that just for fun I used with serverless was that at NAVEX Global, there was a team of people that just for fun used a website called Habitica. It's like a gamified habit task tracking game. And there was an API where you could take certain things that happened in the game, and if you wrote code that would look at that API, you could send that to Slack. And we all lived in Slack, and so all of our notifications would go there. And it was essentially an integration to say, take stuff that happened in the game and put them into Slack, so that every 15 minutes, I would see what would happen. And so that was a very, maybe 100 lines of code that ran in Lambda, and it ran on a schedule, and I never had to worry about managing it.
awesome. Well, thank you for answering all those questions. If you do have more questions, though, here's her LinkedIn again. I already put it in the chat box. Oh, hey, Chris, by the way. Chris has actually graduated from one of our boot camps.
Absolutely. I agree with that.
Oh, good, Chris. Good to have you here. But yeah, so thank you so much, Alexandria, for this presentation. Also, as you guys know, we're recording this session. So if you do want to watch it back, it'll be in our Tech Talk playlist. Let me just re-insert that in the chat. Here is that. Also, next week is going to be our last Tech Talk of the year. Then we'll start again in January. But next week, we are going to have Matthew, who is going to talk about just how to get prepared for interviews, just in general. So it's going to be a lot of tips. Great Tech Talk to join. Here is the link for that. Other than that, thank you all for joining. Thank you, Alexandria, for doing this presentation. And have a great weekend, everyone.
Thank you, everyone. Thanks for having me.
Thanks, Alexandria. We appreciate it.
Thank you so much.
Thank you.
Yeah, thanks, Alexandria. I look forward to watching it.
Sounds
I
good.
really do.
Missed it.